Okay, so let's go through the concept 3, pitch and loudness. So these are the two characteristics of your sound wave. So what is pitch? Pitch just means the frequency of the wave. So for example, if I say, oh, something has high pitch, right, means that it has a very high frequency. So if I say something has a very high frequency, back to the topic of general wave, we know that frequency is equal to 1 over period. So if I say frequency is high, right, means that the period must be low. So looking at the very first picture right here, you can see that for this high frequency wave, the period is rather low. So period is actually from maybe one rarefaction to another rarefaction, or one compression to the other compression. This is the meaning of period. So you can see that the period is low. Okay, for the second is your low frequency wave, or what we call low pitch. So for low pitch wave, the frequency will be low. Since frequency is low, right, frequency equal to 1 over period. So frequency is low means that your period must be large. So period, you can see that the period here is rather large compared to the high frequency wave, right? Okay, so the second characteristic of your sound wave will be known as your loudness or volume of sound. So loudness wise, how is loudness compared to? Loudness is actually related to the amplitude of the wave. So for example, if I say something is very soft, your voice is very soft, right? Means that it has a very low amplitude. And always remember, amplitude is the maximum displacement of the particle. So from the top to the EQM, right? Okay, if I say something is very loud, means that it has a very high amplitude, right? Okay, so another thing to take note about this amplitude is that amplitude is also related to the energy of the wave. Okay, so for loud sound, definitely loud sound has a greater energy compared to softer sound. Okay, so of course, let's take a look at checkpoint 10 to see how we do this type of question. So compression rarefaction are sent out from a loudspeaker cone as it vibrate backward and forward. So when you vibrate backward and forward, right, you will actually create a series of compression and a rarefaction. So okay, the frequency of the vibration is roughly 20 hertz. So what do I mean by 20 hertz? 20 hertz just means in 1 second the particle complete 20 oscillation. So point P is the center of the compression. How much time elapses before the next rarefaction arrive at P? Okay, how do we do this question? First thing, right, we must calculate what is the period of this sound wave, right? Okay, so the frequency is given by 20 hertz, right? So the period, of course, we know is 1 divided by 20, which is 0.05 second. So in 0.05 second, the particle will actually do this. Okay, so for example, I draw these 3 lines. So the particle will oscillate. Okay, for example, I oscillate towards the left first. Then after that, I go to the center, back to the center. Then after that, I go to the right hand side, back to the center. So that is the meaning of 1 period. Okay, so how do I know how much time elapses before the next rarefaction? So first thing first, for period, another way to interpret period is actually thinking of it as like this. So from one compression to the second compression, that is 1 period. If I say if I want to know how much time it takes from one compression to the next rarefaction, so maybe I just talk about this first, 1 period. So if I want to know how much time it takes from one compression to the next rarefaction, right, this is actually half a period. Okay, another way to look at this is actually through the displacement time graph. So for displacement time, we know that, okay, for example, right, we know that for compression and rarefaction, it must always have a 0 displacement. So this will be known as your compression. This will be known as your, right here, rarefaction. Then of course, last but not least, will be compression. So this is compression. So of course for one period is from one compression to the next compression. So if I just want from one compression to the next rarefaction, right? This is only half a period. Alright, okay, so given that one period is 0.05, half a period will be 0.025 seconds. So the answer will be A. Right? Okay, so let's take a look at checkpoint 11. So checkpoint 11, we have this sound wave, right? The sound is then changed so that it is louder, lower pitch. So louder means amplitude greater, lower pitch means that frequency is lower. So frequency lower means that period is greater lah. Oh, okay, which diagram represents the new sound? You just need to take a look at which one has a greater amplitude. Definitely is not B. Of course, it's also not D. So the answer is either A or C, right? Okay, next we will need the help of the pitch already. So if I say something has greater period, right? If you compare option A, the period is actually this much. Then for option C, the period is actually quite large, right? So the answer definitely is C, or C for Canada. Okay, now I move to checkpoint 12. Okay, checkpoint 12 is another O-level question. So we have this diagram that shows the wavefront seen on the screen of a CRO. Okay, for CRO wise, it's just an instrument to measure your wave profile. Right. Okay, how does sound Y? So sound Y is the dotted line here, and compared to sound X. So sound X is the solid line right here. Okay, so for sound X definitely is louder. Okay, what about the pitch? The pitch for sound X, the period is rather low, right? So for example, this is the period of your sound X. So since if you compare with sound Y, right? Okay, sound Y, the period is from here all the way to here. So the period is large. So for sound X, okay, X has a low period. So low period means that frequency is high. So sound X has a greater pitch. Okay, so let's take a look at the option. A is, okay, so Y is louder, wrong. B, Y is louder. Okay, Y is quieter and has a higher pitch. This is also wrong. So the answer actually is D. So Y is quieter and has a lower pitch, right? So that is for checkpoint 12. Okay, so yeah, so that's all for your loudness and pitch. So for this concept, actually it's quite simple.